Hello everyone, welcome to the Ethereum Gas Price Markets with EIP-1559. My name is Tomasz Stanczak. I work on Nethermind Ethereum client project, and I'm excited to show you this new improvement proposal for Ethereum gas price that many people are discussing, many people are excited about and waiting for. So let's have a look what it means for all of us. Maybe before I talk about EIP-1559, I will do a quick recap of the current gas prices in Ethereum mainnet. So whenever you create a transaction, you have to set the gas price on the transaction first. And if you set it too high, the transaction will just make you overspend. If you set it too low, you may end up waiting for a long time before the transaction is included in the block. Because what miners do, they will just collect all the transactions created by you and other users of the network, and they will put them into mempool, and then they will sort them by the gas price from the highest gas price to the lowest. And they will create a block and include the transactions as long as there is enough space within the block gas limit. And they'll be obviously including the transactions from the highest price to the lowest, because all the transaction fees are being paid to the miner account. So they're just naturally incentivized to pick the transactions with the highest gas price. And this mechanism is called the first price auction, which means that you practically blindly keep bidding without knowing what the final price will be. And at the end of the auction, you just learn how much you paid, whether you won or not. You either not paying at all because you didn't win the auction, or you end up paying the price that you bid. And there are some problems with first price auctions. In particular, the price that you pay very often is just too high. And there's another problem with the current gas price market. When you think about it, maybe it's a bit less clear, but it's really hard to tell what the real gas price on the market is. And why is it so? Mainly because the miners are allowed to include transactions in the blocks which are their own transactions. There's really no way to forbid that from happening. And the thing is, whenever they include those transactions, very often they will include them at zero price, or if they want, they may include them at arbitrarily high price, which means that if you ever try to rely on the gas prices from the block, you may simply have it all confused because of the miner transactions. And whoever tries to set the gas prices for the transactions they create very often will choose some kind of average from the previous blocks, which again might be distorted by the transactions from the miners. And since the transactions that they create, the signers of the transactions, are not priced properly, everyone else is misled by those hints from others, and everyone is either overbidding or bidding not enough, making those mistakes, and hence we simply cannot tell what the real gas price on the market is. So here comes the EIP-1559, and it tries to solve the problem by introducing a set of parameters. Probably the most important one is the base fee that's added to the block header. This is something that fluctuates between blocks and is calculated by protocol. And apart from base fee, which is a minimum gas price that has to be paid for all the transactions that are included in block, we have a gas premium, which signers of the transactions add to the transactions themselves. So they work very similar to what the current gas prices do. So they work as a tip to the miners. So if the more you pay as gas premium, the more likely the miner will prefer your transaction over others. And then there is also fee cap. So this is the second part of the current gas price model, which is limiting how much you will pay for the transaction. So fee cap just says whenever base fee plus gas premium is above the fee cap, I'm not really approving to pay that much. So I'm just not approving that base fee. And even if you don't set gas premium, then if the base fee is above your fee cap, you will just not accept the transaction to be included in a given block, and you'll wait for the better times. The block gas limit itself remains voted on by the miners. However, we changed slightly that meaning of the vote. So we no longer vote about the absolute limit of the block. We vote for the target. And the target means that we can create blocks that are up to 2 times the size of the target. As for the base fee adjustment mechanism, it's all based on how big blocks are being created on the mainnet. So if the blocks created are the perfect size in a way, so they match the target gas limit of the block, let's say 10 million, and then the base fee will remain stable. If the blocks created are bigger, up to 2 times bigger, then the base fee will be rising. It means that we actually want less people to post transactions and less transactions to be included in blocks. So we just raise the base fee until we get to the desired block gas limit again. And if the blocks are created on the network which are empty or simply below the target, then the base fee will fall, and it will encourage more users to post transactions now because there is some extra capacity. We are below the target. We want the blocks to be bigger. One important property of EIP-1559, which many people are excited about, is that we're burning the transaction fees. So what is defined by base fee will be burned, will not go to the miner. And that's super important from the perspective of what I mentioned before, which is preventing the ability of the miners to manipulate the base fee price, the gas price. So they no longer can post any transaction with any gas price they want because the fee will simply not go back to them. It will be burned and it would be at severe loss. This burning is exciting people because it's simply meaning that there will be less inflationary pressure on Ethereum. Less Ethereum would be created net of rewards because some of the Ether will be burned as part of the transaction execution. As for the fees themselves, let's analyze a few scenarios. When, for example, fee cap is greater than base fee plus premium, what happens then? So fee cap practically has no meaning in such a situation. You simply say that as a signer of transaction, you find to tip miner a bit and that you'll pay whatever base fee the header has. And in such situation, you see that transaction is paying, everything is paid by signer, premium and base fee, but majority of that value will be burned and just the tip and the premium will be paid to the miner. I'm saying majority, but really the base fee can be really low and your premium can be very high. So in such situation, miner would still earn majority of the fee and only some part of it would be burned. But it really depends on how busy the blocks will be created. In the cases when the blocks are more or less empty, you won't have that much of the burning because the base fee will be very low. Then we have another scenario when actually the fee cap, while it's bigger than base fee, it's still lower than the base fee plus premium, which means that you decided to limit your the size of the gas price that you're paying below the current state of the network. So the base fee is so high that you cannot really approve covering the premium that you promised before. So some of this premium have to be foregone by the miner, and the transaction can still be accepted by the miner if they want, but the premium will be cut by the fee cap level. So still everything is paid by signer, and still very similarly we burn base fee and miner gets some part of the premium limited by the fee cap. And the last scenario really is very interesting. Actually, it's a subsidized transaction. So you set the fee cap so low that it's below the current base fee on the market, which means that if the miners decide to include your transaction, they can still do that, but it will have to cover the remaining fee that you didn't cover. So you say like, okay, the base fee is 10 GUI and my fee cap was 9 GUI. So the miner says, that's all right, I'll subsidize the remaining 1 GUI for you, and everything will get burned, which means that the part that miner paid was burned, they subsidized it, they lost it. And we can try an example calculation of EIP-1559. So let's say the target gas used for a block voted by miners is 10 million, which means that the gas limit really on the block can be up to 2 times bigger than that, the target. And we have a very important parameter, which is called base fee max change denominator, and it defines how volatile the base fee will be, how quickly it will adjust itself if there are big variations in the block sizes. So let's work with an example where we have a gas used 7.82 million on a block, which is below the target. We set the target for 10 million and the gas used is 7.82. So we want the next block to be bigger, and to encourage that behavior, we'll be lowering the base fee. The base fee in this particular block, for our example, is 1 GUI. We calculate the delta from the gas used on the parent block that we created and the target gas used, and in our case it's a negative delta. And delta can be positive if the block is above the target, and that would change our calculation obviously in other direction. And the base fee that we calculate is a parent base fee plus the part of the parent base fee that is multiplied by, first of all, the delta, so the difference, and the ratio of the delta to the target, and then limited by this base fee max change denominator. So we just limit how quickly we move towards the target. And here, as an example, we have 0.97 GUI gas price calculated for base fee. And we can have an example of the calculation with full blocks happening on the network. So whenever a full block is happening, our delta calculation will be really equal to target gas used. And in such cases, we'll be using the entire parent base fee in the second part of our equation. And we'll be moving by the denominator at every single block. So 1/8 of the parent base fee change every single time. So we see here after 8 blocks, we reach the level of 2.28 GUI, starting with 1 GUI. Let's see the opposite scenario. So the blocks created are empty. The delta in such case will be negative. Negative at the level of target gas use, which makes the second part of the equation just -1 multiplied by the max denominator, so the max move, max adjustment. And again, we'll see after 8 blocks, we reach the 0.34 GUI, so it's around 60% below the starting point of 1 GUI. Now we see the last possible scenario that is interesting to look at. The blocks are actually at the desired size. So all the blocks are created, as in our case, at 10 million. And it means that practically we don't want to change anything. So the base will be stable, will not move. Every single block will be at 1 GUI. Now, why I think that EIP-1559 is particularly exciting for the gas price markets. So most important thing for me is that the base fee will be observable on chain. So something that you really don't have access to at the moment from the perspective of the virtual machine will be available for any smart contracts. And we started working on a product that is creating some kind of hedging scenarios that are based on the observable base fee. So you can take into account the gas price that can no longer be manipulated by the miners. So in the past, if you would like to post information about the gas price to the smart contract, it might have been just totally manipulated. If you build any product on chain that would try to react to the gas prices, anyone would be able to trade against it and manipulate the market if they were, any miner would be able to manipulate the behavior of that smart contract. This is no longer possible, and this is super exciting. So obviously, just the basic goal of the introduction of EIP-1559 happens as well. So we should see much less volatility of gas prices, much more predictability. People will be able to know what exactly the direction of the gas prices is recently, and use the wallets, adjusted wallets UIs to have a bit more of a more likely have their transactions included around the actual gas price as it is on the market. Thank you so much for listening, for staying with me, and there are plenty of links available online that can give you much more details about EIP-1559, so have a look at the EIP itself, about the discussion around the inefficiency of first price auctions, the Controls here is a behavior of the systems, as we would like to have a system that auto-adjusts the gas price. Look at Ethereum Magicians and research for all the discussions happening there around EIP-1559. Look at the previous implementers calls where multiple ideas were discussed, discarded, or actually accepted into EIP. Fantastic simulations from some of the teams that are analyzing the behavior of the miners and market participants in different scenarios. Also some alternative solutions like gas escalator. And if you're interested in any links for the images used, they are here. Thank you so much. Thank you.